All right, guys, follow along carefully here. Okay, the points of the atomic theory, obviously there are 4 of them. Okay, here's essentially what I'm looking for, and you can use your discretion a little bit here. Okay, first point, okay, all things are made of atoms. Okay, if they have something about all material or all matter made of tiny particles, okay, something along those lines, that's the gist of the first point. Okay, the second point, okay, is that atoms of the same thing are the same, atoms of different elements are different, okay? So if they have something along those lines, you can give them a mark. Okay. The third point talks about what happens to those atoms when a chemical reaction occurs. They can combine in what? The key words here were, if they go into a compound, they have to be in whole number ratios. Okay? If they do not have the part about whole numbers, okay, and combining in whole number ratios, they don't get that mark, because the whole numbers part is kind of the key part there. Right? And the fourth one, okay, is that atoms, okay, can be separated, joined, okay, or rearranged, okay, but not changed. All right, meaning you can't turn lead into gold is essentially what we're saying with the fourth point. So if they have something about not being able to change an atom's structure, you can give them a mark, okay, for having essentially the gist of the fourth point. So 1 mark each for those points. Okay, who came up with those 4 points? Seth? Dalton, right. Okay, 1 mark for Dalton. They don't even have to have his first name as long as they have his last name. Yes, yep, that's fine. All right, for number 3, okay, name and describe the particles in the atom. All right, what are the 3 particles that make up an atom? Okay, neutron, proton, electron. Okay, and you must have not only the name but the charge correct as well. Okay, neutral, positive, negative. Okay, they got all 3 right, they get 3 marks. There's no half marks there. All right, you have to match the name with the proper charge to get the mark. Okay. Which of those 3 particles did Thomson discover? The electron, right. Okay, who proved the existence of the nucleus? Right, Rutherford. Okay, he did the gold foil experiment. All right, so Rutherford's the answer for number 5. And for number 6 says draw a picture of de Broglie's model of the atom. Okay, if they have something like that is the nucleus, showing that they know the protons and the neutrons are in the nucleus, okay? And they got well, actually they should have the same number of electrons around the outside, okay? Or they have cloud written around the outside, that would be fine too. As long as they drew the electron cloud model showing protons, neutrons, and electrons in the right places, okay, give them a mark. Since I didn't specify which atom in particular, okay, if they have a nucleus containing protons and neutrons and a cloud containing electrons, give them a mark. Okay, whole thing is out of 12. So give them a mark out of 12 on the top, let them see it. And once you've handed it back and looked at yours, please come and put it up here in the period 4 box. Okay, we had done the first 5 of these molecular compounds. Quick review. An ionic compound has what in it? Right, a metal and a nonmetal. All right, and in there we've got the exchanging of electrons. Okay, we've got special naming rules that include, okay, listing the metal first, then the non-metal, changing the non-metals ending to "ide." All right. Once in a while, we might need a Roman numeral on a name if the metal has more than one possible charge, and really that's about it. All right. We also have to remember that when we build the formula, we use the swap and drop. For molecular compounds are made up of what? Two nonmetals. Since there's no way to balance the charges in a molecular compound, since both things are negative, we don't try. Right? Instead, we use prefixes in the name to indicate how much of each atom there are. All right? And so we had gone over the first 5 yesterday. So what I want you to do now is finish the rest of this. So do 6 through 15. Okay, I'll give you a few minutes to get started on those, and then we'll go through them together. All right? So basically today, guys, we're really going to be practicing and reviewing skills of naming. Okay, prefixes are 1 for mono, okay, 2 for di, 3 is tri, 4 is tetra, okay, 5 is penta, 6 hexa, 7 is hepta, okay, 8 octa, 9 is nona, 10 is deca. Okay, make sure you write those down so that you have them. How many people are done up to, let's say, 12? Okay. All right, so let's have a look at up to that point then. So we did 1 to 5 yesterday, so we'll look at number 6 here. We've got oxygen and sulfur together. There's only one oxygen, and I don't use the prefix mono on the first one if there's only one. Okay, so this is oxygen monosulfide. Okay. For number 7, I've got 3 silicone and 4 phosphorus. Right? The prefix for 3 is tri, so trisilicone, tetra, phosphorus. Okay. For number 8, I've got sulfur with chlorine. There's only one sulfur, so I write it exactly that way. Sulfur and then dichloride. Okay, for number 9, we've got 1 silicone and 4 hydrogens. Okay, hydrogen is acting as a non-metal obviously here because it's listed second. Okay, so we have silicone tetrahydride. Okay, and for number 10, we've got boron and carbon together. Okay, so we have tetraboron, tricarbide. Okay, that compound doesn't really exist. It was just a naming exercise. Okay. Yeah. No, I mean if you put carbonide, I would understand that. Okay, but usually we take a little bit off the end of the element when we add the ide. Okay. For number 11, okay, we've got arsenic and selenium. So we have diarsenic, okay, triselenide, or selenamide, however you wrote it. Okay, for number 12, we've got sulfur with bromine. Okay, so that is sulfur dibromide. Okay, how many people have done 13 through 15? All right, so just about everybody here. We'll just go through them then. Okay, so 13, we've got nitrogen with sulfur. So we've got dinitrogen, okay, trisulfide. Okay, for 14, we've got phosphorus and sulfur, and 4 and 8 here, so that's tetra phosphorus octasulfide. Okay, and for the last one, we've got tellurium dichloride. What do none of my names have? No capital letters. Okay, make sure you're breaking that habit if you're still doing it. Oh yeah, absolutely. And you'll get a fresh one because you'll probably have lost yours by then. Plus, I don't know how much stuff you write on it. Okay, but yeah, you'll get a fresh one. Okay, questions on any of those? Okay. Yes. Oh, it should be phosphide. Yes. Okay. Any other questions there, guys? All right. Now, it's easy when you know every one of these is a molecular compound. Okay? But when you start throwing in different kinds of compounds into a list, then you have to think a little bit more. All right? So the next step here is I give you a list of compounds. Some of them are ionic, some of them are molecular. Some of the ionic compounds require Roman numerals and some don't. Okay? And it's can you do it on the fly? Okay? Can you look at these compounds that are all in a list and apply the right rules? All right? That's the step that we have to make here. All right? So there you have it. Now, one thing we haven't gone over yet, and we do need to go over before you do these, is how to do ionic compounds that have in them what we call polyatomic or complex ions. All right? If you look on the top of your periodic table, okay, so let's call that up here. Your periodic table, okay, looks something like this. The table of polyatomic ions is this rectangle up here at the top. Okay? In there are special ions that seem to stick together for some reason. All right? The majority of them are negatively charged with the exception of ammonium. Okay? So the second one down here in the first column is ammonium. It is the only positively charged polyatomic ion there is. So most of them, since they're negatively charged, are behaving as metals or nonmetals. Nonmetals, because nonmetals have negative charges. So the majority of these, okay, when you're writing out a compound's name, will be listed second. Right? The nice thing about these is if you notice that there's a polyatomic ion in a compound, you don't have to worry about its name. Just write it exactly as it appears here. You do not need to put it, don't need to change the ending to "ide" or anything like that. You write it exactly as it appears on there when you write the name of the compound. All right? So it's pretty easy that way. The only tricks are when you're writing the formulas. Okay, and we're going to talk about that in a little bit. So we'll look at one of our examples here that have the polyatomic ions in them. So let's look at number 9. Right? I've got calcium, and then I've got SO4. All right? Anytime a compound has more than 2 elements, it has a polyatomic ion. All right? So then you go to your chart and you find that polyatomic ion. Okay? What's SO4 called according to your chart? Sulfate. Okay, not sulfide. Sulfide is just sulfur. Okay, sulfate is SO4. All right, there's also sulfite, which is SO3. Okay, so in this stuff here, if this is calcium and this is sulfate, this stuff is calcium sulfate. That's pretty easy, right? Okay, not too much to it. All right, all the rest of the rules apply, same as before. If you have a complex ion with a multivalent metal, then you put in Roman numerals. There aren't any here. Okay, but kind of gives you an idea of where to go. All right, so give these ones a try. I'll give you a few minutes and then we'll go through. Okay, so for our first one here, I think we've actually had this one already once. Okay, so we've got lithium and chlorine together. Is that ionic or molecular? It's ionic. It's a metal and a non-metal. All right, so we don't need any prefixes in this one. It is simply lithium chloride. All right, for number 2, we've got chromium, which is a metal, with fluorine, which is a non-metal. When we look at chromium on the periodic table, though, we notice that it has 2 possible charges. So its name is going to require what? A Roman numeral. Okay, we have to figure out which Roman numeral. Chromium can be a 2+ or a 3+. It's with fluorine here, and fluorine is -1. If there's 3 fluorines and each of them's -1, this chromium is chromium 3, right? Okay, so chromium, Roman numeral 3, okay, fluoride. Okay, for this one here, for number 3, we've got phosphorus and bromine, both non-metals. So we've got phosphorus tribromide. All right, for number 4, we've got zinc and iodine together. Zinc is a metal, iodine is a non-metal, so this is ionic, and we have zinc iodide. Okay, number 5, ionic or molecular? Someone? molecular. It's two nonmetals. Okay, so again, we're going to need a prefix on the oxygen. So silicone dioxide. Okay, for number 6, ionic or molecular. Molecular, again, both nonmetals, carbon and sulfur. So we have carbon tetrasulfide. Okay. For number 7, okay, a very rare metal combined with a nonmetal. So it's an ionic or molecular compound. Ionic compound. Okay, so we have technetium heptaiodide. Okay, number 8's your first one that has a polyatomic ion in it. If it has a polyatomic ion in it, it's what kind of compound? Ionic or molecular? Ionic. If it has a polyatomic ion, it's an ionic compound. Okay? Just in case you were ever lost on that. Okay? If it has a polyatomic ion, it is definitely an ionic compound. So, in this case, we have a metal, sodium, with this. How can I tell if a compound has a polyatomic ion in it? It has more than 3 elements. Okay? Or sorry, it has 3 or more elements in it. Then it has a polyatomic ion in it. So, sodium is its own element, then oxygen, then hydrogen. That's 3 elements. So we're looking for a polyatomic ion. If we go to our polyatomic ion chart, we see that OH is called hydroxide. So this stuff is sodium hydroxide, right? Okay, for the next one here, this is the one we did as the example. All right, so we'll just write it in calcium sulfate. And if you spell that with a PH, that's fine. Don't spell fine with a PH, though, because it's spelled with an F. Okay, all right, number 10. I've got potassium and then this MnO4 stuff. Have I got 3 elements in this compound? Okay, so do I have a polyatomic ion here? Yes, and in fact, anytime you see brackets, you have a polyatomic ion. So, okay, this stuff here, K is potassium. Okay, and MnO4 is permanganate. Okay, these are little purple crystals. They're very pretty. Don't touch them, though. They stain your skin brown. Okay? Yeah. Okay. I used to do a lab with this stuff, and I always would tell the kids before, make sure you don't handle this stuff with your bare hands, use the scoop and whatever. And this one kid who never ever listened, he went, Mr. Codere, can I just grab that stuff with my fingers and put it in? I figured it was time for this guy to learn how to listen. I said, sure, go ahead. Okay. Next 3 days, fingers, brown. Back to like the second knuckle, all the way around. Okay? Yeah, and it stays that way until your skin exfoliates. That means comes off. All right. So he had like brown fingers for several days. Okay? It was very funny. All right. He totally deserved it because he never listened. All right. So the lesson to be learned here: don't touch potassium permanganate, and listen when I tell you instructions, or I will get even. Okay. Yeah. Well, there's other things. In fact, it used to be used as an antifungal. All right. If you had bad athlete's foot, you would make a solution of this stuff and dip your feet in it. Your feet would turn brown, but okay, it would kill the fungus. So you would turn brown, yeah. And you wouldn't get any fungus growing on you anywhere. Yeah. You'd be brown and fungus free. Okay? Yeah. All right. If your skin's already brown, it's not a big deal, right? You don't notice it so much. But this guy was like pasty white, okay? And yeah, so it was very obvious he had these brown fingers, okay? All right, number 11. We've got nitrogen and oxygen together. Ionic or molecular? It's molecular. Okay, so there's only one nitrogen, so no prefix. Nitrogen monoxide. All right, and then number 12. Okay, again, we've got a polyatomic ion here. Does it matter that there are 2 of them if it's an ionic compound? No, ionic compounds don't get prefixes, so this stuff is simply beryllium cyanide. Okay, cyanide is very, very poisonous stuff. Okay, if you were ever to ingest it, it blocks one of the pathways your cells use to burn sugar, and you die pretty quickly, actually. Okay, so you don't want to ingest any of that stuff. All right, the next one here, we've got cyanide again. This time, instead of with beryllium, it's with barium. Okay, so barium cyanide. Okay, 14. We've got sodium, and then hydrogen and carbon and oxygen. Is this a polyatomic ion? Yes, it is. It's a what? Right, there's 3 elements. It still makes it a polyatomic ion. Okay, so this stuff here, sodium. Okay, and what's the name of HCO3? Hydrogen carbonate. So sodium, hydrogen carbonate. What's the common name for this stuff? You probably have some in your pantry at home. No, salt is sodium chloride. This is baking soda. Sodium hydrogen carbonate is baking soda. Okay. All right, and number 15, we got phosphorus with 4 oxygens. That's molecular. Okay, so we've got phosphorus. Okay, tetra oxide. All right, questions on any of those? All right, so that's the naming stuff. Writing the formulas, okay, is actually pretty easy. All right, we're just going to quickly go over how to do the formulas, and then I've got some worksheets that you guys are going to practice on today and tomorrow. Okay, on Thursday, you'll be moving on. I won't be here, but there'll be podcasts played by the sub, okay, and it'll be like I'm here, except you don't have to look at my ugly mug at the front of the room. Okay, so the smartboard will be very smart and teach for me, okay, on those days. Yes, you will get another quiz on Thursday, and I'll tweet it tomorrow. Okay, and it'll be on naming. Oh, if you're not here, you don't worry about it. Yeah. Okay, so moving on here, Captain.
Sorry, this may sound like a stupid question, but would nitrogen actually make that stuff?
Not nitrogen in and of itself, no. Okay, if you have it in conjunction with oxygen, in other words, nitrous oxide, yes. Okay, nitrous oxide is a catalyst that releases more oxygen into the combustion chamber, allowing you to burn fuel more efficiently. Okay, unfortunately, it usually also will destroy your engine in fairly short order if it's not designed to take it. Okay, all right. So converting chemical names into formulas. Okay, how do we do that? Well, okay, the first thing you have to do is identify whether you have an ionic compound or a molecular compound. That should be pretty straightforward. We've already talked about how, okay, molecular compounds have 2 nonmetals, whereas ionic compounds have a metal and a nonmetal. Okay? So if you find you have, let's say, an ionic compound. So let's say we're given the following name here. Let's say, oh, let's say we're given this name, okay, and we're told write the formula for this compound. All right, so the first thing I do is I write the formula for the metal and I write its charge beside it. Where can we find the charge? Right beside the element on our periodic table. All right, so the formula for potassium is K, and you can see on your periodic table it has a charge of +1. Then I do the same thing with the nonmetal. All right, the nonmetal we're dealing with here is nitride. That's N. Okay, and its charge is -3. What do I do with those 2 numbers now? Okay, I make it so that it's neutral the easiest way. Okay, what do I do with this? Right, I put the 3 in front of the K. We call that the drop and swap, or swap and drop, whichever order makes more sense to you. Okay, so I take the 3, I put it down here. I take the 1, I put it there, but we don't write 1s. Okay, and now we're done. That's our formula, K3N. Okay, is everybody all right with that? All right. Only time the swap and drop method will fail you is if you get a compound where you get 2 even numbers or 2 numbers that you could be divided by the same number. All right, so we'll look at, let's say, this example here. Okay, We get magnesium oxide as an example, all right? So I do this thing that I just did. Magnesium is 2 plus, oxygen is minus 2, and if I drop and swap, I get Mg2O2. Should I leave it that way? No, I always reduce down to the lowest terms, okay? Can both of those numbers be divided by 2? I hope so, in that they're both 2, okay? So if I reduce this down, I just end up with MgO. Okay, it happens once in a while, just be aware of it. Okay, if you have like lead and oxygen, you could have 2 and 4, and you would have to reduce down to 1 and 2. Okay, things like that. So that's about the only time the swap and drop will mess you up. Okay, is if you have 2 numbers that can be reduced. All right, everybody follow me on that one. Pretty straightforward, the swap and drop. Okay. Molecular compounds are even easier. They're even easier because they tell you what numbers to write. That's what the prefixes are for. All right, so if we've got this one here, okay, with tetraphosphorus decaoxide, the tetra means there's 4 of this. The deca means there's 10 of that. All we have to do is put in the numbers that match the prefix. Okay, so let's do this one here as an example. Okay, so if I get that, nitrogen dioxide, there's no prefix on the nitrogen, so how many are there? 1. All right, so I write N. All right, and then I've got dioxide. How many oxygens are there? 2. Done. Okay, that's all there is to it. You don't have to do any dropping and swapping or anything like that. Just write the numbers that the prefixes tell you to write. Now, on this one here with P4 and O10, probably a few people are going, Coder, you just told me if I get those, I should reduce them. That's only true on ionic compounds. These were the prefixes you were given. Those are the numbers that go on there. Okay? You never reduce a molecular compound, just an ionic one. Okay, what if we get, let's say, a compound like this? And the name has a Roman numeral in it. Now what do? Does it change what I was doing before? Not too much, okay? The formula for iron is Fe, and what does the 3 tell me? It doesn't tell me that there are 3 of them, it tells me that the charge on iron is 3, okay? That's what the Roman numeral was for when we put it in the name to indicate which iron we dealt with, okay? So that's saying use the iron with the 3 plus charge, and it's with nitrogen that has a minus 3 charge. Does that add up to 0? Okay. There's your formula. Okay? Fen. Right? Another situation you could run into, you could have a polyatomic ion in the name. So we could have something like calcium hydroxide. Okay, if I have that, is this an ionic compound? Has a polyatomic ion in it. Is it an ionic compound? Yes, it is. Okay, so I write down calcium and its charge, just like I do for any other. And then I write hydroxide, OH, and its charge is -1. Can I drop and swap? The answer is yes. I can drop and swap. It's an ionic compound. Okay? The only trick to swapping and dropping when you have a polyatomic ion is what you do with the number that goes on the polyatomic ion. If I write the compound like this, how many oxygens are there? 1. How many hydrogens are there? 2. Is that the way it should be? No. It should be like this. I need 2 hydroxides. Okay? Now it says that there's 2 oxygens and 2 hydrogens. Anytime you have to put another number beside a polyatomic ion, you use brackets. It's probably a little easier to see that if you're dealing with something like this. Magnesium nitrate. Okay? So I write magnesium, Mg is 2 plus, nitrate is NO3, and it's a -1. Right? When I drop and swap, the 1 goes here. I don't write 1s. And the 2 goes over here. So if I don't put brackets around this, what is this saying? It's saying there's 32 oxygens. I'm pretty sure that's not the way that's supposed to go. Okay, that's why if you have to put a number with a polyatomic ion, you have to put it in brackets. Okay, now they know that there are 2 nitrogens and 6 oxygens, as opposed to 1 nitrogen and 32 oxygens. Okay, makes a lot more sense that way. All right, that's about the only trick. All right, with me on that one. Okay. All right, so what I'm going to do here is hand out the first of the naming and formulas worksheets, and you can get started on that today. Okay, and then we'll be kind of practicing that stuff most of the day tomorrow. There's only about 15 minutes left today. So, okay, on the swap and drop, the negative and positive don't go with the numbers. Okay, so when we do this for calcium, okay, it's 2 plus, phosphorus is minus 3. I don't write Ca negative 3 and P plus 2, because if I have negative 3 calciums, I have less than nothing. And that doesn't work. Okay, so just take the numbers. Ca3, P2. Dropped and swapped, there's your compound. All right, remember, you only do the drop and swap for ionic compounds. For a molecular compound, and there aren't any of those on this right here. I think these are all ionic until you get further down, okay, to like 15. Okay, 15 is a molecular compound, diphosphorus, P2, pentaoxide, O5. You're done, right? There's no dropping and swapping on one like that. Okay? All right, keep going there, guys. Okay, you can check because the keys for all of the worksheets you're going to get are on my website. Okay, so if you go to the website here, and then you go to Science 10 Notes and Assignments, and you go into Chemistry. Okay, you'll see down here key. Okay, key or naming key, naming key, naming key. All of these. All right, just open those up and match it up with the sheet you're doing. All right, I would say this, guys, use those keys, but obviously don't just write down the answer that's on the key. That doesn't do you any good. Also, don't do the whole sheet before you check, because if you've been doing it wrong, how many times have you practiced doing it wrong? Like a lot, 50 maybe? Okay, we don't want to do that. Do about 5 and then compare to the key. All right, do another 5, look at the key. Do another 5, look at the key. Okay, and see if you're doing it right. That's the best sort of way to go about doing that worksheet and making sure you're not practicing bad habits or anything like that. All right. I'm seeing one thing coming up here on a lot of people's sheets, and it's number 3. Okay, what do the Roman numerals tell us? They tell us what charge to use. They don't tell us how many of that thing there are. They tell us what charge to use. Unfortunately, I'm seeing a lot of this, Mn4O. All right? The 4 doesn't mean there's 4 manganetes. It means, okay, that use the 4 plus charge when you drop and swap with oxygen. Okay, that's what the Roman numeral is. Remember, manganese has more than one possible charge. We have to tell people which one to use. That's what it's for. Okay, so that one should be MnO2 because you can reduce it.